A very good morning, dear students. Welcome to the world of chemistry. Good morning, dear students. Welcome. Today we are going to start our chapter 4, that is chemical kinetics. And this is very important chapter. Chemical kinetics. Let's understand the meaning of chemical kinetics. As we have finished our unit 3 yesterday. So dear students, it is my request from you all, please go through all the questions that is given in exercise of unit 3 and feel free to ask me if any doubt is there. So today we are going to start the introduction of chapter with the help of a flow chart. So let's start. So this is digital classes and unit 4 chemical kinetic introduction. So before going to start the introduction of chemical kinetic, let me tell you some of the important things that you should know in a chemistry. Chemical reaction. You know very well about chemical reaction. You studied in 10th class also. You are studying from junior classes also. Everything that is changing and forming a new substance is called chemical reaction. So the feasibility of that chemical reaction mean that chemical reaction is going to be occur or not, is going to be happen or not. That feasibility is totally depending upon thermodynamics. For any chemical reaction, thermodynamics tell us about the feasibility of reaction for any physical or chemical reaction. Okay, in which delta G should be less than 0. We have studied this in +1 class in thermodynamic chapter at constant temperature and pressure. Whereas that chemical reaction, whatever chemical reaction is there, how long that chemical reaction is going, how long this reaction is going to be proceed, that is telling us about the chemical equilibrium. So chemical equilibrium tells the extent to which a reaction will proceed. And now the third, chemical kinetic, it tells us about the rate at which a chemical reaction proceed. It means that the speed of chemical reaction. Okay, one thing is that whether chemical reaction will occur or not, that thermodynamic, we come to know with the thermodynamic. The how long the reaction will go, that equilibrium. Okay, because reaction is keeping on going until it will not attain equilibrium stage. Okay, that we studied in 6th unit of chapter 1, class +1. This we studied in unit 7 in class +1. Today we are studying chemical kinetic. So let's understand the chemical kinetic. First, the meaning of chemical you know very well, which is the chemistry of elements. And kinetics is what? It is in Greeks, the word come from kinesis. The kinesis mean movement. Okay, and the movement is what? It is just from one place to another place. So basically this is the branch of chemistry that deal with the rate of reaction. What is rate of reaction now? It is the time taken by any reaction. It is rate mean time taken by any reaction. This is the branch of chemistry deal with the rate of reaction and the factor controlling it. Basically these are the factors that control the rate of chemical reaction. Number 1, concentration of reactant. More the concentration of reactant, more faster will the reaction. And temperature, more will be the temperature, more faster will be the reaction. Catalyst, it will increase the rate of reaction without involving itself. Surface area of the reactant, as you know that in evaporation also, more the surface area, more will be the evaporation reaction. Nature of the reactant and product. Yes, obviously, if the reactant is dilute, it will take less time to get product. If the reactant is concentrated, it will quickly form the product. Okay, so this is also nature. Presence of light. So these all things we are going to study in detail in our upcoming topics videos. So dear students, I am going to divide the whole chapter into basic 4 parts. One is rate of reaction, second order and molecularity, third is integrated rate equation, and fourth is dependency of rate of temperature. So one by one we will finish it. These things are interlinked with each other, so you should learn in this way. So first, rate of reaction. There are instantaneous rate of reaction that we need to understand, average rate of reaction, unit of rate, rate law, rate constant. One question is coming definitely from this part in 1 mark. Either it will come from average rate of reaction, unit of rate law, or rate constant. Okay. Second part, when once the student is well aware about all these terms and units, he know what is the unit, what is rate law, then we need to understand the order and molecularity. What is order and molecularity now? If we will take a simple example of any reaction, suppose A plus B. So you see A plus B, how many reactant are taking part here? 2 reactant, and it will form AB. We will not see the product because product always formed by reactant. So here most important is reactant. So how many reactants are there? 2 reactants are there. If 2 reactants are there, these are called biomolecular. If 1 reactant are there, then it's called unimolecular. If 3 reactant are there, then it will call polymolecular. So molecularity is what? It is the number of species that are taking part in an elementary one-step reaction. Okay. So before going to start properly this topic, you should have a little bit idea about that. Whenever you are going through to see the reaction, you need to focus on reactant. How many molecules are participating in reactant? That is called molecularity of reaction. Okay. And second, you when you are doing balancing, as you did in 10th class also, when you are doing balancing, whatever number we are writing on balancing coefficient side, that is somewhere known as order of reaction. So it is the sum of power of concentration term. Sum of power of concentration of the term in the rate law. It is the sum of power. When we are writing any reaction in equilibrium, you write, suppose here 2. So 2 is the order of reaction. Okay. The 2 is the order of reaction. If we will write B also here, the 2 plus 1 sum. 2 plus 1, 3. So 3 is the order of reaction. Okay. So order of reaction can be calculated like this way. Suppose for example, K is rate constant, A plus B2. So B molecule is 2 time and A is 1 time. So 1 plus 2 is 3. So its order of reaction is 3. So what is the difference between order of reaction and molecularity? Molecularity is number of species taking part. Here the sum of power of concentration is the order of reaction. Okay. So this is very important topic, and most of the questions are coming. Define order of reaction, find order of reaction, calculate order of reaction on molecularity, and sometime question is coming, difference between order of reaction and molecularity. Okay. Third is integrated rate equation. Here we need to find out the derivations and some numericals also, which are related to these order of reaction. So basically there are 4 order of reaction: 0 order of reaction, first order of reaction, second order of reaction is also there, pseudo order of reaction. So 0 order of reaction is totally based on the concentration of reactant. It is independent to concentration of reactant. We need to find out 0 order and half-life of 0 order. Similar way, first order and half-life of first order, it is depending upon the initial concentration of those order, and it is pseudo word means false. So it is actually not first order but looking like, behaving like first order due to some condition, that for example hydrolysis of ester. Okay, these all things in detail we will study here also. This is also important in the form of derivation and numerical. Then after when we will once do rate of reaction, order of molecularity, and we come to know integrated rate of, then last we will study about dependency of rate of on temperature, mean on which factor the rate of reaction is depending. So first is temperature coefficient. It is the ratio of K298 to 308. Try to understand. It means that rate of reaction is going to be changed after each 10 degrees Celsius. Suppose student is increasing 10 degrees Celsius, if we are increasing 10 degrees Celsius, so it will change the rate of reaction and it will change the ratio of reaction. Okay, so this is the ratio of K298 to 308 of every 10 degrees rise in temperature. That factor we will study. Arrhenius equation, very important, in which one equation has given by Arrhenius to calculate the ratio between two rate constant, okay, by using this formula. So we will focus this formula. We need to just see carefully this formula. Again and again we are going to study in future. Then activation energy, it is the energy required by reactant molecule for effective collision to form product. Basically how the reactant is converting into product, because those reactant are colliding with each other, striking with each other, and going to be mixed with each other and forming a larger compound. Okay, so how much energy is required to collide? That is called activation energy. Threshold energy is minimum energy required to start any kind of reaction. Effect of catalyst, with you know about the catalyst in bio also, you studied also. So catalyst is what? These are those substances which promote the rate of reaction, which increase the speed of reaction. Okay, these are basically transitional elements. Collision theories, what is happening when two elements are colliding, that chemistry we will study. So this is all about that we are going to study in this particular chapter. So dear students, before going to tell you anything, once again I'm going to tell this video. Dear students, thanks for watching this video. And till my next video, stay home, stay safe, have a nice day. Once